And now the fun stuff starts. This is let's take a look at why I choose to use a skeleton sketch part in my projects designed in SolidWorks. The main thing is that I can change the dimensions of my project in this assembly, skew them in whatever direction I want them to go very easily. Remember, all these files are all sharing this equations. All these parts are sharing the same equations file. So if I open that up and I come in here to equations, I can see all of the parts, have their dimensions linked to an external file. In this case, this is where the location of the file is. I've got it set to automatically rebuild, and got all the boxes checked here. And so now what it means is if I want to change the dimensions of something, I just get into this simple little text file here and say, instead of a 6-inch box, I want it to be 12, and I want it to be 24 by 24. All I have to do is save it, rebuild it, and everything. Maybe rebuild it a couple of times. Get the dovetails to calculate, or the finger joints to calculate out correctly. I mean, that's all there is to it. Change the dimensions of the box, and I can make it. If you look all around it, it's the box is still intact. Everything's there. Now, one of the things that, the second thing I would like to maybe change, or I might like to modify, is if I say, I look at this and I like a finer tooth pattern on the in the tenon count. So I can go from 3 to say, well, that's a 12-inch box height. I'd like the teeth to be maybe, let's say, 3/4 of an inch. So, or 1 inch, let's just say 1 inch. And so let's do 1 per inch roughly there, and save it and do a rebuild, and complete rebuild again. There you go. So now I've got 12 tendons per side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. So now I've got this nice fine tooth pattern there. And if I want to change it back, I don't like that design for whatever reason, I can put it back to my 6. I think we can do this 6 and some just random 18 length by 12, make it 12 wide, and go back to the side tenon count of 3. Yeah, do 3. So I want it to be 3, so I can show you the next thing that we're going to do here. So let's revert that back to this. Okay, takes a little while, a couple of rebuilds to get this stuff replicated down to the mirrored parts. Okay. I don't think that took the 3, did it? Did I miss something? Oh, let's go back down to 3. Apparently didn't save that. Okay. All right, and I'll show you in a second why I wanted to do the 3, because it's not just the dimensions that you can check. You can also check, this idea of a tolerance. Here is that you've got. The tolerance can't be 0, or the parts won't mate. It's because the two lines would be occupying the same. Both the edges of both parts would be occupying the same point in space, so you've got to give them a little bit of a gap to slip together. And in my woodworking, 1/28 of an inch, which I realize is ridiculously small, it seems to work pretty well for me. But how do I know if I've got it applied? If I've set the tolerance, every joint there's a tolerance on every side. Well, I've got a really easy way to do that. Let's go back to the equations file. What if we make this tolerance 1/8 of an inch and not 1/28 of an inch? Now it's going to be bigger, and the problems become much more obvious. So let's rebuild this. couple of times. There you go. Now look. Have I got that tolerance? Is everyone... Now there's several problems that could happen when you're applying the tolerance. One of them you could have, just oops, you forgot. It's not there. You didn't, when you were building the model, you didn't realize that there was an edge that needed a tolerance. You didn't put it on there. Another common mistake is to apply the tolerance to both sides, both parts. So you've got, so the gap would be twice as big as it should be. That's another one. So, and there's a third one that slips my mind here for a second, but you can see at the bottom, I've got the tolerance so wide that the bottom gap has kind of disappeared from the board, but that's okay. The main thing is I'm checking to see that I've got this, the tolerance is evenly applied all the way around the joint. And I know if I've got one corner, I'm pretty much assured that because of the way I've done things with repeating sketch patterns and mirrors, that I'm pretty sure I've got it all the way around. I don't need to over-examine. But that's one quick way to test your tolerances. So I'll put it back. Oh, 128. There we go. All right, and I'll move it back to default location, rebuild a couple of times. There we go. Now we've got, we go back to, we want to go look and make sure the bottom's got tolerance. So I can do it another way, is I can just make it, we can hide a couple of parts. Do something like that. Go down and zoom in and see if we got a tolerance all the way around it. See the dotted line? I've got a tolerance all the way around the slot, so that should fit just fine. Now I'm going to go off in the weeds now. So this is let's think outside the box, so to speak. This is a case, if you were to look at it from the front, just if I flip it over and do it from the top, what is that? It's a bookcase. How is that not a bookcase? You drill the holes down the side, which you can easily do with a CNC, and you got a bookcase with box joints at the top. Another way to look at this is, this box and the dimensions that it's set at, it's a drawer. It could be a drawer of any size. So if you're building a chest, this can be, this is your drawer box. Now, I've started experimenting with some things that I don't have. I'm not prepared to. Maybe I'll get into in another video. But I mean, if you were to replace this front piece and make it an oversized drawer, the tenons here, because we're cutting it with a CNC, and I mean, why not? These tenons can stick in the back of the drawer front. It doesn't need to be. I know in a lot of woodworking, you build a drawer box, and then you can have what's known as an applied front, where you get another piece of wood and you put it on the, a decorative piece of wood to put on the front of the box. You don't need to do that. You can take that decorative piece and with the CNC cut holes for these tenons in the back of it and just stick the sides in it, and it works just fine. So. I guess I don't think of this as just a box. What this is a case. It's a case with relatively decorative, joints. This finger joint on the edges. Actually, the thought occurs to me. We need to talk a little bit about this concept of a dog bone. Now, I modeled this assuming that this was a 1/4-inch bit that I've got on my CNC that I'm going to use to cut these pieces with. And I've got a 1/16 inch bit. I could, if I made it the dog bone's 1/4 of an inch, these things turn into, pretty ugly standard CNC looking, looks like a CNC joint. When I see woodworking projects, the CNC projects like this on the internet, when I'm out shopping around, let's get a 1/4 inch. That's not. Yeah, see, that's typically what I see. It's a big, ugly dog bones. So I got to thinking, well, what is the minimum that I need to get around that? And it turns out that I could get by with 1/8 of an inch. So so I cut that in half. I don't know. Maybe I could do it with a 16th. Let's give that a shot. I'm going to change my 1/4 inch to a 16th of an inch here. I don't know, if I had a 16th of an inch bit, I could go around and drill. That's a tiny bit for a CNC, but who knows? Okay, that's and then when you zoom out, which is when you're at this distance, that you can get that dog bone to where it's almost imperceptible. When you're gluing it up, that's not much of a dog bone. It's not very visible. And I've got a couple of projects that I've finished that I can show off how to make that dog bone invisible as well. So anyway, to wrap this up, this little series on the building a box woodworking project with SolidWorks. This is a gateway to a lot of different things, and I think this technique will work really well for building other projects, and not just simple box like this. There's a lot of, I think, a lot wider application. So anyway, that's it for this little series, and maybe we'll explore other things that I've been doing with it in another series of videos.